Alright. We need to stop giving up and we need to start paying attention to learn how to do this. I'm frustrated right now because we are 8 minutes into class and we're 9 minutes into class and we're acting like we have no clue how to write the equation of this function. And not we, some of us. Because, goodness gracious, we've been doing this for a couple of weeks now. And I hear people talking about, oh, I don't know the rate of change, I don't know blah, blah, blah. What do we know about this function to help us get started? Is there anything that we know? Say again,
What type of function it is?
So I need to know what type of function it is, and what were you about to say, KP? It's not what?
Never mind.
Okay.
I want to say the wrong one.
I mean, I cannot help you if you do not start somewhere.
No, you just ended it. I was resubmitting these. Can you change
It's
mine?
fine, as long as you had something in, it's fine.
No,
I
I'm
need
saying
to
though,
focus.
I'm talking about the right answer.
But remember, this is all about learning and growth. It's not just about getting the right answer. I need you to try something. Jay Sean? Okay, so I will say, he's claiming y-intercept is 400. Can anyone tell us why that would be the case here?
Because when the input is 0,
But remember, it's more about where the x is 0. It's the output when the input is 0. But remember, that's not what tells me the type of function. The rate of change does in a table. But what should we immediately recognize? And here's the thing that I'm frustrated about. It shouldn't take us 10 minutes to figure out what type of function it's definitely not.
It's not linear.
How do you know it's not linear?
why you say linear?
It's fine. Let it go. It's not constant what? Additive. To go from 625 to 500 is minus 125. To go from 500 to 400. Shikai, are you engaging in this? Because you said you didn't know the rate of change.
I did not say
You literally did.
You're gonna beat me up. So.
500 to 400.
I'm just real.
Okay, I'm sorry. You didn't say those exact words, but you said I give up because I don't know what's happening here. So then you don't know what the rate of change is. You literally said I give up. So 400 to 320. Minus 8. Right away, we should have known it's not what? It's not constant additive, so it is. Well, so it's not linear. That's all I'm asking. I talked about this, by the way, the other day, where I said, what's going to frustrate me?
Not trying.
Not trying. Not everything. Not trying. 7 minutes into class and us have not even really started, that's going to frustrate me. And if you're upset with my attitude, please understand that that is why I'm frustrated, because you are super capable as a human being and as a thinker and as a mathematician, yet you're getting in your own way because you won't even try. And then you get upset that you don't know how to do stuff. We should know within 30 seconds, I'm not kidding, we should know within 30 seconds this is not linear. I'm not saying we know what the equation is, but within 30 seconds we should know it's not linear. Knowing it's not linear, I have several people up here that I have a 2/3, I do have a 4/5 and a 5/4. How can we find what the rate of change is? Jay Sean.
I did 500 divided by 6 foot.
Why did you do that, Jay Sean?
I remember you said that you.
405.
Say again, Jay Sean.
I said I remember you said that we could do that to find rate of change.
If it's multiplicative rates of change, if it's an exponential function, I have now covered this multiple days in class where you can just do that division. Huh?
You did it yesterday. Don't lie. You did it yesterday.
KP. It was actually on Monday, which was the second time I covered it. This is the third time. Because yesterday was a linear function. KP, you sleep and don't pay attention all the time. Don't tell me what I did and didn't do.
Hey, y'all stop hollering. 4 divided by 5 is the answer.
Thank you, Saquon. Notice 500 divided by 625. That's 4/5. Notice I could have also done it with the 400 and the 500. I would do 400 divided by what? 500. And what do I get again? Say it one more time. 4 divided by 5. Meaning that we're repeatedly multiplying by what? by 4/5, or 4 divided by 5. You cannot learn, guys, if I care this much more than you do. And some of us are caring, some of us are engaging. I'm sorry, Petway. But guys, I've taught this multiple times. And KP, last week we did a practice sheet where we wrote the equations of linear and exponential functions. And it was then, when we had multiple problems, that I first showed y'all that you could do that division to find the multiplicative rate of change. And then I reviewed it again on Monday, and I'm going back over this again today. And if you check it, 400 times 4/5 is 320. 320 times 4/5 is 256. So it's what type of rate of change? That way. Press. Off the iPads right now. Engage in the whole class conversation. Stop complaining.
I ain't even complaining. If I complain, I would have been here.
That way. That's literally complaining. If you want to ask a question, respectfully, Mr. Kinney, can you turn there off?
We'd had a peaceful protest and y'all want to argue.
I said, maybe you cut it out.
That's not what you originally said.
Oh,
So,
No, he was teaching. So wait.
there were also black students in here who cared about their education.
I ain't see no.
So, we know it's what type of function? Exponential. So what's the equation
Why equals
for exponential? And guys, please hear me very clearly on this. If there was evidence, enough evidence to believe that there was something truly racist that happened and not someone just lying about an administrator, because a lot of the evidence that I've heard both from students and from teachers that a particular student lied about an administrator and what they said, I'm just telling you, the evidence that I have
His mom told
heard,
that girl did and her mom did. I didn't lie.
I'm telling you, I heard it from both students and other teachers that someone was lying. Okay,
And their story.
so, and here's the thing, there's conflicting reports. There's not enough evidence to go one way or the other. If there was, then I would have been out there as well. But I'm here, I have a job. My job is to teach and to help students get an education. And if there was a conclusive evidence, then I would have been there as well. But your education matters.
You talking to me?
Education
I'm
on
talking
first.
to our class.
I was not telling education on first. Put a name on it.
It ain't mine for you.
I literally said,
Oh, you understand what you said?
like, so,
These niggas were crazy.
language. So what is the value for A?
400.
400. That's my
400.
y-intercept.
Times 4 over 5x.
For what?
4 divided by 5x. That's what I said.
Like that?
No. Put it on top.
So as in,
Exponential.
You gotta
Use your
put
language.
parentheses on it.
No.
so if you don't put parentheses around it, then it would, okay, so here, this actually says that you're only doing 4 to the x, not 4/5. So you do want parentheses around it to indicate that that 4 is being divided by 5, because remember an exponent happens before division, but when I put parentheses around it, that puts the division first. Does that answer your question? Okay. So once again, I have taught how to write the equation of a linear exponential function. We are going to be testing on this content next week.
Next week.
No, it's not too early. We spent 4 weeks on this. Actually, I lied. We have spent 2.5 weeks on this. We cannot go longer than 3.5 to 4 weeks because we have too much to cover. Okay. So, there's that. There's also videos on YouTube that you can watch. I have tutoring multiple times a week for you to get the education that you need. Y'all have me for enrichment. Instead of sitting around and goofing off, you can come and ask me questions. I'll be more than happy to answer them. You can do all those things to be successful. It is your choice. So,
My hair.
Saquon.
Hold on, crazy. man.
So, just as a heads up, not everybody, but some of y'all have been referred to peer helper. If someone comes during enrichment to help you, take advantage of that extra resource to get that helping during enrichment.
What that mean?
That means somebody coming to help you because you're not on the same level as everyone else.
That's not what that means. That is not at all what it means.
No, I'm talking about the refer, but that mean you refer to somebody?
Yes.
So it's not like an office referral, it's just saying that I recommended that
Recommended because
someone help you
it's
with
a little slower.
completing, no, someone, no.
Mr. King, they were there, go help you.
Headway, if I'm literally saying no, don't tell me what it is. This is what I'm over in this class. Y'all wanna argue with me while I'm trying to help you, don't argue. The fact of the matter is that people need help to be able to learn successfully, and so I might recommend you. If you want to be recommended for peer helper, let me know.
I just said,
Okay?
can we know?
I'm trying to wish.
No, I'm not going to announce to the whole class who I recommended and who didn't. No.
Did you recommend me?
Huh?
Did you recommend me?
I'm not telling you in the whole class. If you want to come talk with me,
He wants you, he don't care, he wants you to tell him.
I'm just wondering.
Yes,
So-
he recommended you. Actually.
we are looking at Desmos on the iPads at this point, and then we are going to work on Matthew at the end of class if we have time. You have a homework assignment on Matthew?
Am I supposed to get off the bus?
We have homework.
You have a homework assignment from Matthew. I told y'all about it yesterday. It's what you started in class
So the
yesterday.
Carnegie learning.
That's why I asked you.
Look, are we doing anything else with these?
If we get done with the Desmos activity, we will work on Matthew. We need to focus on Desmos so we can learn about the forms of quadratic equations.
Let's go.
So, go to student.desmos.com. If you log in, you do not have to actually use that code again. Once you log in, you just continue or open the activity we have.
Hey, what's the code?
I go to the library.
You don't need the code.
I go to the library. I do.
No.
I never logged in.
Y'all can't get on there.
Hey, Mr. King,
Since I was 12.
I don't know what I need to do.
I thought we
No, have you logged in?
I'm logged in, man. I'm logged in.
So, oh, it's right there, open. Guys, if you've logged in, the activity is already there. You just click open.
What's fun?
Oh my gosh.
We'll go to slide 2 in a second.
Alright.
Z, did you not get logged
Tell
in
me what the
yesterday?
homework was.
Oh, I got it.
I never got logged in.
You logged in?
No, it never let me log in.
You never created an account yesterday.
It never let me create an account.
Hold on, let me reactivate the code. It's TV.
That's what I was trying to do. It wouldn't let me do it.
Okay, it's activated. Okay. Is there anybody in here who did not get the code and get logged in yesterday? Trey, go to student.desmos.com. You need to create an account, and your code is going to be CYMYTV. So once you go to student.desmos.com, enter that information in. At this point, I need someone to read our first objective for us.
Let's go, guys.
Saquon?
I can identify the three. Huh? You said you're talking to me.
No, I was talking to Kristen, headphones out.
I can identify the three forms of quadratic equation.
There are 3 forms. Does anyone remember the names of those 3 forms? Standard form is one. If you look at the sheet from yesterday, it's on there.
Slope intercept point.
Those are for linear.
Factor.
Factored is one.
So
Vertex, standard, and factored form are the 3 forms we're looking at. Okay? Anybody else not have this sheet that we absolutely need today? John, do you have your sheet?
Good sheet, bro.
Sure. Thank you.
Sorry, I was trying to make sure Saquon did not see yours. Where's yours, Saquon?
In my book bag.
Get it out.
You gonna pass my book back to me?
You're standing next to it. Mr. Kwan.
I'm giving you.
Education.
Sir.
It won't let me.
So we have those three forms. You need to know your three forms.
No, Mr. Kenny, I don't have it.
I'll come and check it in a second. Oh my gosh, guys, you got the boxes underneath the desk. They're somewhere. Grab one.
I don't have it, Miss Kenny.
Can't make this.
Miss Kenny.
I'm trying to get class started though. Y'all know that you have these boxes.
Are you mad? Let's do it.
Can you just really see so I can get started?
I want to take it.
Okay. Listen guys, there are three forms of the quadratic equation. You need to know their names and you need to know what the actual equation is.
Let's go.
From those three forms, what's the next objective? Hold on a second, Jay Sean, I'll come and look at it. Can I get somebody to read the second objective? Joe, sit down. Well, Sam volunteered first.
Read it.
It's all good.
I can identify the features of a parabola based on the form of a quadratic equation.
So you're so smooth.
So, please understand, there are features of a parabola that we want to look at. What are the features that we can look at on a parabola?
Concave, up or down?
So concavity. What else?
The line of symmetry.
I found it.
Line of symmetry.
And if it's below,
Okay.
Usually
Say it
it's
right there.
below the line, like that.
X-axis.
X-axis.
If what's below the line though?
The vertex.
Okay, so the vertex is what we want to look at. So guys, concavity, vertex, line of symmetry. Haley, Shakai, and Janaya. If y'all's eyes aren't even up here, how are we engaging the whole class conversation? I'm trying to tell you the things to be successful, and y'all just crap on it every single day. That's frustrating. You stress me out because you don't engage. Congratulations, we're on the same playing field.
You know what you need? Fix
So-
that first. Cigarette.
Don't smoke.
Stop. Stop. So the features, what are those features we are looking for today?
Vertex.
Vertex,
Concavity.
concavity,
Line of symmetry.
line of symmetry. There are two more features that we will look at for every relation we ever study.
Oh no.
Any guesses or remembering?
Vertical line test.
That's if it is a function. So good memory on that vocab term.
Oh!
How about the x and the y?
Axis.
Not
No.
well, it's where we're going to intersect the x and y axis, so the x and y intercepts, okay? So those are the features that we're going to look at, and we're going to use the Desmos sliders to look at the different features of the parabola based on this equation. So we should be on slide 2 of Desmos, and Jay Sean will come and help you in just a second once I get this started, okay? If you follow the directions, you can notice the pattern all on your own, and then we will have a whole class conversation about it. On slide 2, what are you supposed to be adjusting?
The
Point.
The value of A. The directions are at the top. Do not adjust the value of H. Do not adjust the value of K. Only adjust the value of A. So, we're going to write whole class notes at the end, and I think we started on this yesterday, didn't we actually? Did we already finish A yesterday? Yes? Okay, so A, what did we say about A then?
When A is positive, the parabola is concave up, and then when it's negative, the parabola is concave down.
So is that a pattern that we see? A is now negative, is the parabola concave down? For sure. When A is positive, the parabola is concave up. So you should already have here under values of A. Did we talk about that notation yesterday?
Yes.
No!
Yeah.
Yeah.
Okay, so what does this
No, we
say?
didn't.
If A is greater than 0.
Zero.
Then
So
it's
what types of numbers are greater than zero?
positive.
Any positives, right? So when A is greater than zero, when we have positives, the parabola
It's up.
is concave up. When A is less than 0, the parabola is concave down. All right. You need to have those foundations there. We need to have that started. Can I see this real quick? Okay. Really quickly, this may happen where you are zoomed out to really weird numbers that don't help you see the parabola at all. There's a little home button right here. Hit home to go back to where it needs to be so you can see stuff. This is the view that you always want. You can zoom in and zoom out, hit the home button to fix it. I do not, but you can borrow from somebody. So hold on a second. Hold on.
I got one.
Hey guys, let's focus so I can finish the introduction. Bryce, I need headphones out. Thank you, sir. So we have the value for A. What values do we now need to look at? We have A. We now need to look at
H and K.
H and K. We are now on slide 4. Yep, because we did slides 2 and 3 yesterday. Please remember that it says now we are adjusting which values?
H and K.
H and K. Are we adjusting A at all? No, we are adjusting H and K. And please notice I'm asking what happens to the graph. And then how do the values of H and K explicitly connect to the graph? Hear me clearly on this. Adjust H and K and see in general how it affects the graph. But afterwards, find H and K somewhere on this graph. I have already given you what key points on the graph that are marked. Hey guys, right here. What points have I already marked on the graph? What's this black point?
3, 4.
But in general, we want to recognize that's my vertex, right? Because remember, we want to think about the features of that parabola. We have our vertex. We have, what are here?
Points.
Not just any old points. X-intercepts. Those are x-intercepts. And here?
Y-intercept.
Y-intercept. So what I'm asking you to do is identify where these values show up in the parabola. They explicitly connect to somewhere.
Yes.
Once you have a prediction, all you need to do is use the slider to move stuff around and make a prediction. Once you have the prediction, move to slide 5 and make sure you answer those questions. If you finish slide 5, move on to slide 6 and so on and so forth. We'll come back together pretty soon. I'm going to make sure Jay Sean gets set up. I'm going to listen in on your conversations as we talk through these things to help you develop a better understanding of the mathematics. But we need to get to work. So Kwan, since you're on your own, do you want to jump or join that group over there?
No, I'm fine here.
Okay. Can't actively collaborate there. That in general, H translates the parabola horizontally. So what does K do?
Translate the vertical, translate the parabola vertically.
Okay. Sorry, we need to start raising hands so we're not shouting over people like that. So we're translating the parabola vertically. But remember, there was more than just that we wanted to talk about. We wanted to connect those values to the what of those parabolas.
Vertex.
Well, we're going to talk about the vertex in a second, but the vertex is a feature.
Way to start.
Right? Feature is the
Oh, my bad.
remember, we're trying to connect these values to the features of the graph. Those features would be the vertex or the y-intercept or the x-intercept or already said vertex, line of symmetry or concavity. Remember, which we already discussed it. What's controlling the concavity for this function?
The positive and negative slope.
Which positive and negative? The A. We want to recognize that the A is controlling that.
A greater than O or A less than O?
Okay. So H and K. I know for sure that group 5, I know for sure that group 5 has already figured out what H and K are controlling in the parabola. Has anybody else figured out what H and K or what feature of the parabola H and K show up with?
Not H, K controlling the vertex.
Is only K controlling the vertex?
No, it's right.
Let's look at it a little bit closer.
Both of them moving the vertex.
So, right now, actually let's just do this. Right now, my vertex is 3, -4. What is my H over there, Sam? What does it say for my H right there? H equals 3? Bryson, what does it say for my K? Can you see it?
Yeah. -4.
-4.
-4?
-4.
Okay, so here's what I want us to do. Let's look at some more vertices. Can I get someone who has a vertex other than 3, -4 to tell me what their vertex is? By the way, we know how to identify the vertex, right?
Sure.
Yeah.
Yes.
The vertex, right, is that relative minimum or relative maximum is the black point. Can I get someone to give me a vertex other than 3, -4?
Bro,
based
somebody
on
move
what
the
they
lines
see?
on their computer.
-8, -5.
Okay, so -8,
1.
-5. Okay, hold on, and we'll pause for there a second. Alright, so, Ryder, what is your H value?
-8,
H is -8. What's your K value?
-5.
Okay, KP, H is 1, K is 1. Well, it's just 1. Can I get one more point, please?
Hold on.
-5 and 2.
-3 and -7.
And so what is H? -5. K is?
So H is X and K is Y.
It's, okay, so let's pay attention to this. We want to add a little bit more clarity to it. H is the X of what? What point is this?
3, 4, 3, 8.
No. In general, what point are we describing in each of these ways? So H is the X value of the vertex. So K, what is K?
What is K, John? The Y value.
Y value of the vertex? John, are you involved in this conversation? Because it looks like you're staring out the door, which means you're not paying attention up here. John. John. My man, are you going to get an education like this?
Batman.
Good talk, man.
He mad with Batman.
Oh, no, I'm not.
Stop. So, let me ask you this, and this is the point. And we're going to come back and check this out in a second. But if I am looking at y equals a times x minus h squared plus k, how would I write my vertex out of that information?
Wait.
How would I write my vertex off of this equation?
Substitute.
But what's the vertex going to be? Hey guys,
H
H and K?
Yeah, -HK. 2
Do notice,
negative.
hold on, we're going to talk about that in a second. You're bringing up a good point, but
Hey, we still putting that under value of HK.
yes, this is still under the value of H and K. You don't have to rewrite this, but you can. We want to notice that the vertex is H comma K. Yes, Jay Sean.
I'm lost.
Where are you lost, dude?
I don't know what we doing.
I'm just a lost boy.
Jay Sean?
Nowhere to go.
Hey,
No place to go.
Quan.
Nowhere to call home.
Jay Sean,
Why they ain't gonna say I don't know what we doing? I don't understand.
what do you not understand?
Like what you doing the equation? I don't get that part.
Okay, you know that the equation is the equation that we're studying, a times y equals a times x minus h squared plus k. That's known as the vertex form of a parabola.
I don't know that.
Okay?
I did not know that.
Okay, look at your sheet of paper where it says vertex form of a quadratic equation. Bam.
I see it.
If I.
Yeah, like that.
You see it now, Jay Sean. Do you understand?
Nah,
Hey, KP.
I'm trying to.
I know, but let me cover it. So Quan, stop. So,
What I did?
Jay Sean, right here, what we did is we looked at 4 different vertices. Hey. But Jay Sean, we looked at 4 different vertices from 4 different people, and when I asked them, hey, what h value did you have in the graph? The h of 3 was the x value of the vertex. The k value of -4 was the y value of the vertex. You see how this is the h and this is the k? So every time, and what Saquon said was that the x value of the vertex is h. So if I want my vertex, what's taking the place of the x value and that vertex? That h. So that's all that this is saying. X value of vertex. You good with that now? Okay?
Now what's K? Tell me what K is.
Of what?
Good job.
So crappy.
Y value of
Vertex.
vertex.
That I never see the day.
Hey John, have you taken a single note on this, my man?
Don't be tripping.
Bro, yeah, I'm saying, bro, don't just say no man.
How are you gonna learn?
Hey, leave John Claire alone. He gonna get mad. Hey, that's not funny. I gotta report it.
Okay, I'll just take it. Just worry about your own education. It is what it is.
You hollered at him, probably mad.
You hollered at Batman?
Dude, stop making
Stop.
John Clay gonna play it.
Alright.
Jab you on your shit.
So, we need to recognize, at least at this point, we need to be able to identify what A, H, and K are.
Yeah.
Wait, so will HK be in the parentheses?
The H and K are not inside the parentheses. Look at that purple equation and look at this one. First off, what is A in this equation?
3.
3. And that's important because A is controlling the what feature?
The initial.
Hold on, hey, we get the key to the paper, right?
Yes.
Concavity
Down here,
feature.
Right, the equation that has the example.
The concavity feature.
The concavity is controlled by
A.
A. So that 3 is telling me about my concavity. What is H?
Echo.
It is.
H is 7. Jay Sean?
Would 3 be the starting point?
No. So we have to be careful. The starting value, that y-intercept, is a feature that we focus on with linear and exponential. It's different here. So remember, Jay Sean, that's why we adjusted this value of A earlier. Notice if I change what A is controlling the what of that parabola. Look up on the board. Jay Sean, what I'm putting over there on the board. What is A controlling?
What? Who moved it? Okay.
Right. That
She
A
actually moved her
simply
iPad.
controls our concavity. H, somebody said
Self.
7?
Self.
You would think that, wouldn't you?
No, it ain't
No,
self.
it's not.
Oh.
It's 49.
It's -8.
Negative. It's negative, that's why you put in parentheses, baby.
Right here, and
Chill.
this
No,
is, hey guys,
chill.
this is the most common mistake students make, and I need you to pay attention to this so you don't make this mistake.
Yeah, I didn't negative.
Right here,
Look, see?
you see where it says x minus h? Remember how you were talking about negative h earlier?
Yeah.
It's not negative h, but because we're subtracting h, I always need the opposite of what's inside the parentheses.
But right, that is
Then why you
X.
got
So, huh?
Like, oh God.
Well, this is x plus 7.
Don't believe how bro.
How do we get that plus 7? Because it was x minus a negative 7.
Oh.
You see how it's x minus h? So h is that negative 7. So we get x plus 7 because we subtracted a negative 7. Right. So with h,
So
we
whatever-
always need the,
What's up in there? You flip the sign.
you need the opposite.
So if it was minus, we still flip the sign?
So if it was minus self, you put just self. Correct?
In this case, h would equal a
Positive
positive
self.
7. You always need the opposite of that h value, or what's inside parentheses.
So that's just the base of what the equation supposed to look like.
That's the formula for the vertex form. Remember, there's 3 different
What's
equations.
behind you? That's what it is.
That's
What's
the formula for the vertex form. And so we can identify the A, we can identify the H, and we can identify the K. What would K be?
Negative 8.
K will be -8. Oh, you
Notice-
gotta change it?
You see how it says plus K? Whatever sign is there, that is the
The
k
opposite.
value.
Word.
You only need the opposite here because it's x minus.
For sure.
You only need the opposite here because it's x minus. This is the sign, that's what I go with. So minus 8 means k was a negative 8.
That's weird.
Well,
And that's confusing.
Yeah, it is. I'm not gonna lie.
Yeah.
I will go ahead and tell you,
-8.
everything horizontal
I get it now.
always acts the opposite of the way it appears.
I get it now because whatever
Okay.
equation you write, it's gonna be opposite.
It's going to be opposite.
I-
Even, and look, this is not what we're studying, but right here, you would think that we're actually multiplying by a half.
But we're
What you would
not.
actually do here is you would multiply by 2 to the x values.
This.
Everything horizontal acts the inverse. Right? Does that make sense?
No, you just lost me.
My point is,
Where did the division sign come from?
Huh?
We can just get divided by from.
no, I was pointing out that everything horizontal acts the inverse. So,
So what if it was flipped?
hold on.
Oh, geez, man.
Look, this looks like it's supposed to be a negative 7. It's actually the inverse, a positive 7.
It would.
Here, this looks like I'm multiplying by a half, but it's actually the inverse, so it's multiplying by 2. That's all I'm
So
saying.
why wouldn't it just be inside the what's the name of it? The absolute bar.
The absolute. I mean, the parentheses?
The absolute bar.
We don't have absolute values here.
Do you know what I'm talking about? Though?
You're talking about absolute values, but we don't have an absolute value function. We have a quadratic.
When it's negative 7, why won't you put it in the absolute bars to?
Well,
So
it's
we can
always
know.
the opposite. It's not, so absolute value always makes it positive. It's not always positive, it's the opposite. What?
Everything.
Okay,
It's confusing.
if it's positive
What are we
7,
switching it for?
it's the opposite, it's negative 7. It's,
What's your favorite?
okay,
Don't let him talk to you like that.
let's say we have this point right here, right?
Yes, sir.
And I'm just gonna make up an a value of 2. If I wanna write this equation, that's my vertex.
So 2.
I get 2 parentheses x minus what?
3.
No, negative 3. Because I'm subtracting a
When I said
negative,
3,
That
because
It's gonna be a
that's what I know. That's why I said 3.
Machine fader.
so, but if I asked, what am I subtracting? Keep your hands down, especially because I'm recording right behind you.
Oh, we can't see me.
Uh-huh.
Alright.
X minus a
A
negative
negative
3. Because it's subtracting a negative, it
Gonna be a
becomes
positive.
positive. My point is that you always need the opposite to get what H is. It's the opposite
So
of what we
at
see
the
in
end where it
parentheses.
say plus 7, you change it to negative 7.
It's the opposite,
For
yes.
sure.
If it's horizontal, it's always the opposite. Okay? So
So if it's vertical, like say we doing vertical.
like the K, it stays exactly the way it appears. So we have our H and we have our K. The last thing that we have to look at here is, I believe if we look at slide 6, it asks about the line of symmetry.
AJ Squirrel.
Where would can I get someone to come up here and draw the line of symmetry through this parabola?
Me!
I had my hand up.
KP had his hand up first.
Yeah.
What he thought he was
He
doing?
did have his hand up first.
Let's go, KP. Come on,
I have my hand raised
Bill.
as I was getting up.
I saw his hand first.
Come on, Perunta in the building.
Wrong.
What now?
That ain't no line, dude.
It's close enough. It's close enough.
Dude,
Come on.
I ain't good.
How was that being productive? Was it? Did you know?
Don't let me
that was
because he
supposed
erased it.
see, that just took even longer. You had the first
to be-
time.
It was fine.
Nah, do look better.
That was way
Okay.
See, they,
So-
they hang.
Is there symmetry around this line?
Yes.
100%. Now I need you to pay attention to this line and to understand how we write the equation for this line of symmetry. So right here, this is the point -3, 9. That point right there. This point is -3, 7. This point is -3, 1. This point, the vertex is -3, -4. What do you notice about every point on that line?
Well, what's the name stays the same?
What stays the same?
What's
The
the
X
name?
value.
The X value.
The x value is -3. In this case, so if I wanted to write an equation to say that x is always -3, what would I do?
But ain't it
Made
positive?
it.
It's on the right side, so ain't it positive?
Oh, you right. Why you let me lie to you like this?
Yeah, I was talking to you.
I said that machine one.
I did not hear you. My bad, KP.
He ain't open his lips.
God, I did.
Stop.
Stop lying. dude.
Stop.
Dude, stop calling me the N-word, dude.
He didn't just say that then, did he?
No, I did not.
Yes, he did.
Stop. Never mind.
Let's just focus on our
Get back to
learning.
work, Drew.
Stop.
For real, you tripping.
Come on,
Stop.
come on, Perrell.
Please stop. Y'all should be amazed that I keep my cool as much as I do.
That's why I be saying, I would have been lost,
And
man.
I appreciate it, but
I don't think
you
way
need
too
sometimes.
You don't care about
Hey,
you.
You get the
You
word.
ain't the
You
teacher.
what they talking about. They get the word.
So, how would I write an equation to say that x is always 3?
X equals.
Would x equals 3 say that x is always 3?
Yes!
No matter what the y value is, x is equal to
3. Oh, God.
And I want to point this out. Sam, what is this h value right here? 3. Because what does this line have to go through? It has to go through the vertex. Wait, so x is equal to 3. That's my h value.
H value.
Okay, so let's change this parabola really quickly. Now, my parabola's over here. And this is my axis of symmetry.
Hey, stop.
I did that so
What would the equation for that axis of symmetry be if this point is -4,
How you want it?
-4? X equals, is every x value -4 on that line?
Yes. X equals negative.
I mean, if it ain't no line of symmetry.
Okay, so what we're saying is, and this needs to go into the values of h and k, the line or axis is x equals, you have plenty of space underneath those problems there that you can write. The line of symmetry is always going to be x equals what?
X equals
H.
whatever,
Oh, snap.
whatever H
What-
is.
Whatever h is, right?
Yeah, for sure.
For sure, right? So line of symmetry, x is equal to h.
Whatever H.
So if I want to know my features, I need to identify my a, h, and k to get started. And this is where you have some practice problems.
Bro!
You can also see this on slide 7 if you go to that slide. Or you just do it on a piece of paper. These are the same equations. So if I want to identify the vertex, which values control the vertex? Let me finish giving instructions. What values control the vertex?
The H and K value.
H and K. So I need to identify the H and K.
Yep.
What value controls that line of symmetry? The line of symmetry is not A, line of symmetry.
X.
Oh, wait.
Saquon?
H.
H. Remember, it's x equals h. And if I want the concavity writer, I'm looking at
Can it be a negative?
Can what be
Line of
negative?
symmetry.
You can have x equals a negative, yes. Okay, so work within your small groups. Let's fill out the vertex, the line of symmetry, and the concavity for those 3 equations. No, hey guys, we're not looking at the graph. We are using our knowledge of the equations to figure this out.
My only friend was the man
Remember,
with
it's
the
all based on
moon.
A, H, and K. Let's talk about it.
Come on, Haley.
Hey,
I'm waking my group up. We're gonna get our participation points.
Saquon, but it's how you do it, man. Dude, pitch a fit again. That makes it better. I'm saying that we're about to have a whole class conversation. Do we not know that when it's whole class conversation time, the small conversations stop? Have I not said that day after day after day? Okay.
Somebody's at the door.
Man, they bullshit, man.
So, vertex for this first equation. Sam, you got it? 3, 4. Parentheses with it. Okay? Bryson, please focus up here. Let Saquon be a part The conversation is a whole class conversation. So, one of the things I talked about with group 3 is what do we always need around our coordinates for a point? You've got to make sure you have those parentheses. Now, I saw quite a few of us writing that the line of symmetry was 3. Does anybody want to add on to or push back on that? It's 4. Line of symmetry is 4? Anybody want to add on to or push back on that?
It's
It's threes.
three. X equals 3.
Okay, so I want to point this out. Sam is saying it's not just 3,
It's X equals 3.
x equals 3.
Yeah.
Remember, and Sam started this conversation off the right way, you said that the line of symmetry is x equals h. Every time my line of symmetry is x equals h. I know, you're good, right? In a similar way, what should we think about every time we're trying to do the vertex from vertex form? H, comma, k.
So you want us to put the variable like equals?
So if you do not say x equals, it does not make it a vertical line. Otherwise, you're just giving me a number. The line of symmetry is always x equals and then whatever h is.
Don't put y.
So, concavity. I did see a group do this. This is the most common mistake we make. I saw a group say concavity is 2. What is actually 2 though?
The A
The A is 2. But concavity is either up or down. The fact that A is 2 tells me that it's concave up because A is positive. Okay? I want to point this out. If you didn't already do this, this would have actually been very helpful. Could you have come off to the side and said A equals and written out what A is?
Yes.
A is
2.
H is
3.
and K is
4.
Good ain't that funny.
That would have helped. So Kyla, does that help you when I write out what A, H, and K are to know how it goes for the vertex and the line of symmetry?
Yeah.
That help? Okay. And you go with that? Okay. Second equation, what's our vertex?
-5 and
Line of symmetry?
-5.
Just -5?
No, x equals -5.
Okay. Concavity?
It's negative
Now.
5.
Okay. Does anybody want to push back on,
Told you it was supposed to be.
push back on, or ask a question about those features?
No, I got my own already.
We got it. We're good to go on that.
Yes.
Wait.
And and remember, it's not just about getting it right. It's about making sure we understand why it's
I
right.
give you.
Yes.
Okay.
Why is right?
I put the explanation.
Good.
Why is right?
So,
Yeah, you're right.
third equation. What's our vertex?
-1, -9.
Never mind.
Saquon?
Never mind. They said it.
Okay. -1, -9. That's what you're gonna say.
Yes, sir.
Okay, Saquon. What are we gonna say for the line of symmetry then?
X equals -1.
Okay. Concavity.
Down.
Concave down. Make sure we include that detail about concave down.
Oh, I just put up, down, down.
Okay. Notice I even put whether A is greater than or less than 0. That'd be part of my evidence of
Do
understanding.
we have to put the A is greater or less than?
That would be on an assessment. That would be the justification, right? That would tell me why you're saying concave down.
Otherwise, just put concave up or down.
Right. Okay.
In the next one.
Vertex.
-8.
No.
Whoa,
No, it's positive A.
Positive 8?
Positive
Why do you say it's positive 8?
Negative.
Whoa, we're talking way too much over people.
If you look at the
Stop
vertex
talking.
form, it's y equals a parentheses x minus h, and the h. Well, it's because you're not because it's not a plus sign, so you're not.
Okay, and so Shamar, what were you saying? We need the what? Remember, that's the language, like, we need the opposite, right?
Opposite.
So we need the opposite. Remember, it's x minus h, so
Oh
the
my
h is a positive 8.
So negative.
Huh?
No, it's positive. If it was negative 8, it
You
would
said
say
negative
plus.
8, they were saying it's positive.
Okay.
And
I got you.
x equal 8.
I got
You good now?
Concave or A greater than 0.
Yeah.
Alright. So, that is what we can identify in which form of a quadratic. That's vertex form. In vertex form, we can easily identify the line of symmetry,
The concavity.
vertex, and slope, concavity. We are now going to look at which form on the back. Standard form, okay? Trey, can you read the equation for standard form? If you ever have a quadratic, notice that's the very clear second degree function, specifically polynomial, second degree polynomial that has three terms, ax squared plus bx plus c, then that is the standard form. Notice with standard form, which values are we going to focus on?
Why even two?
A and C.
C.
Oh no, A and C. A and C.
See how it says A and C up there?
For sure.
So we're focusing on values of A and C. B does something, but that's not what we're going to look at right now. I'll have to explain that later.
We're worried about A and C.
We're worried about A and C. So notice with slide 8, which is where we should be now, we are going to adjust which value? Slide 8. We're adjusting which value?
A.
A. Adjust value A, play around with it to figure out what A is doing. When you finish that, move to the next slide, next couple of slides. We need to get through A and C within the next 4 minutes.
Let's go.
And I know that sounds crazy, but I promise you it's doable. But we need to actually start moving the slide over value of A. Saquon, please pick up your pants. We're adjusting the value of A. Read the directions on slide 8. What is it? What are we thinking that A is doing? Is it changing concavity? But focus. But think about what you just said. Is A still controlling the concavity? When A is negative, it's concave from its concave down. When A is positive, okay. So we are still seeing that same thing. So make sure you go to the next slide, make sure you can answer those questions there, and then move to slide, I think 10 is the next one where you focus on C. So what do we got going on here? What do we notice?
So what we get, just see.
You can adjust these things too. I know, but, yeah, Haley,
C
Chicago.
moves up and down.
Okay, any more than just that. There is more to it. Remember how H and K showed up directly in the vertex? Okay, that value of C shows up somewhere specifically in the parabola. It wouldn't be the vertex because we already talked about the vertex. What are the other things we can talk about? Okay, what are the other features that we said we're going to be looking at? X and Y intercepts?
C moves up and down.
Speak up.
Talk about that as a group.
Thank you, sir.
I can talk about it as a group. Right. My guy.
I was checking.
But I asked you to do this back.
It was important.
So it could be seriously important. So you're saying that C is moving the vertex up and down? Okay. So I do want to point this out, right? Didn't we just look at the vertex with H and K? Yeah. Vertex point? So I would suggest that we look at the value of C again. It might be moving it up and down, but right now, what's your C value? Don't move it. Leave it right there. What's your C value? C value. You see it on that graph? What point is that?
Jump skier.
It's only on the wire.
So what's that point called?
I'm an earring.
On the y. Is that C my y intercepts every time?
Oh my
Or
god.
it is the y intercept? Is that what you're noticing too?
But I'm so smart.
Focus on the thinking and not talking about how smart we are.
You know, it's actually
Not done that you've tried looking at their iPads, make some sense. You know, it's actually, that's amazing. So I say, make sure you're, that's what we noticed. Okay, so A is still the concavity? Okay, did we figure out what C is doing yet?
She got it up there.
What's the specific word for? I know it's going through.
Translate. But there's something else actually that C is doing. Look at what C is right now. What is C? No, look at that value for C. What is it? Do you see that negative 4.5 anywhere on the graph?
It's like prime.
That's not negative 4.5.
Where negative 4.5?
His C right now is negative 4.5. I'm asking where is it on the graph? What is your C value?
Okay.
Mine is, your C is negative 2? Do you see that I value of negative 2 anywhere on the graph?
Oh, no.
It's on the y-axis? What's that point on the y-axis called? Oh. Wait, so your C was the y-intercept? Is your C the y-intercept?
Even though my right was not.
I was like, look at that. Thank you. Thank you. Okay. So we quickly noticed, or at least all the groups that I talked to quickly noticed that what is A doing to the function?
Hey, doing
Okay, we're almost done.
I don't know
So,
how to explain that. How do you say it?
say what? Hey, listen, guys, listen to these conversations over here, because I heard these groups talking about it. What did A control?
How wide it is.
The concavity again, didn't it?
Yeah.
There is something with the width that we'll talk about later, Bryson. But if A is greater than 0, if A was positive, the parabola was what? Up. Parabola is concave. Up. In a similar way, if A is negative, if A is less than 0, the parabola is concave down. Okay, we had it at the beginning of class, before lunch. All right, hey, for those who have already talked about it, what was the value of C? Y-intercept? So let's check and make sure, and I want us all to see this. So, listen. Leave her hair alone. Leave her hair alone.
I'm trying to tell you what the Y
So,
is.
we want to notice that the C is the y-intercept.
Hey, see the Y.
Listen, whole class conversation, let me drive it right now. Gage, let me drive it.
They wrong for this.
So, hey,
Come on, bro, we got 3 minutes.
there's no way that they're wrong with that has anything to do with this math. Focus. So, the y-intercept, right now, my C value is 4. What's that y-intercept, Sam?
0.4.
0.4. What's your C value right now, Ryder?
0.
No, is it? What's your y-intercept?
0.
0, 0? Okay. Hannah, what's your C value? Okay.
Dude, he has an answer.
Her C is negative 3.5.
So negative 3.5, and what's your y-intercept?
Corn.
0, negative 3.5. So guys, right here, value of C. What is the C controlling? Controls the y-intercept. Specifically, the y-intercept is always going to be what? It's not just a C. Think about a y-intercept. It's a point. What is the first value in that point? Always.
0.
Remember how the x value, the input is always 0 for a y-intercept? So it's 0, comma.
0.
C.
The y value, the y-intercept is C. We will have to pick up there tomorrow. I need my calculators and everything else packed up.
Thank you, sir.
No.
Please note, this Carnegie Learning, if it is not done within class tomorrow or Friday, this is due Friday night. So you might need to take advantage of enrichment to complete this assignment in class and not have that homework. Close the door, please. That bell is not wrong. Tristan, close the door.
Break this up.
That's how